This is the animation of the body movements. Now I'm going to cover the body movements of various organisms. Let's see how our body moves. See, let me show you this experiment through this model. So when the muscles are pulling, the bones are also moving, and the muscles are attached to the bones with the tendon. So how the children can remember for long with the help of a word called bottom. So in between B and M there is T. So they will remember this, that when the muscles pull, the bones move. Let me show you once more. Now, our body not only moves by these muscles, but it allows the movement with the help of different joints. The joints present over here is ball and socket. In the elbow, it is hinge joint, and here it is gliding joint. Let me show you through the model. Here you will find this ball and socket joint. Ball is fixed into a socket which moves and gives a maximum rotation. Next, here in the elbow you can find the hinge joint which moves 180 degree open and close. And here on the wrist you can see gliding joint which glides. Now let me show you how the earthworm moves. This is a model which is made with the help of the wire which is circled and made a spring kind of thing, and it looks like an earthworm. Now, how the earthworm moves, let me tell you that it fixes its rear end and releases it. So it moves, and then again it pulls its muscles, and then it will fix it here, and then slowly and gradually it moves. So this way the earthworm moves. Earthworm do not have any hands or legs or any kind of, they only have bristle like setae here, and they are easily able to move through the soil. Let's talk about this fish. Now the fish has a streamlined body. Streamlined means it is broader here and tapering here, so it helps it to move. Like, it also has a swim bladder. If it has to move down or up in the water, it uses that. Let me show you through the experiment. Here there is a balloon which is there in this bag. It is now sinking, but when I blow, it was floating. The reason is the fish also has the swim bladder like this. So what happens? They blow in the air and they come up and float. So this way the swim bladder helps them to move up and down. Now here there is a butterfly. You can see how the butterfly moves. Art integration plays a very vital role. So when the students do this, they will be able to know how they move. Okay. Now when it comes for movement, we also need to know about the friction of the surfaces. So here I have made this. This is the hoof of the herbivorous animal, say cow, and this is for camel. So you can see it has thick padded feet, and this is the paw of leg of the polar bear. It has no slip soles here, nonsense. Now here I can show you the experiment that why the camel are able to move in the desert. So when they move now, so this may sink, but these are not sinking. Okay. So what's the reason is when the area is more and it is padded, so the pressure will be less. But here the area is small, and as it is allowing it, so while moving, even if we walk, we will not be able to walk because of this. Area is less, pressure will be more. area more, then pressure will be less. So similarly, suppose this is a sheet, very transparent sheet, and the polar bear walks on the ice. So they will be easily able to manage. I mean, they will be able to balance because of these non-slip soles. But if suppose the herbivore goes, they may get slip. Okay. And if I keep this, it is very hard for them to pull it. So this way they will learn how the friction also helps them for. Now let's talk about how this insect was